Alright, so we're going to be spending the vast majority of this talking about addition and subtraction formulas with a little bit at the end. And if you would like to follow along in your books, should you have it, it's 7.2. Alright, so your objectives: you will learn and apply the trigonometric functions of sums and differences. You will use the addition and subtraction formulas to prove identities. And you will graph trigonometric functions. Alright, so let's start with the addition and subtraction formulas. You've got the formulas for sine. Sine of s plus t equals sine of s times cosine of t plus cosine of s times sine of t. Same thing for subtraction, except it's minus. Cosine's a little bit different. You've got cosine of each of them both on the same side. If it's addition in here, it's subtraction out here, and then vice versa for that. Alright. For tangent, you've got tangent of s plus t. So if it's plus on top, minus on the bottom. If it's minus on top, plus on the bottom. The top you just add tangent of each of them, and then on the bottom 1 minus the two multiplied together. Okay, so hopefully you can see a little bit of a pattern between those two. Alright, so for example, to find the exact value of the cosine of 195 degrees, we need to use the formula that you just learned and were shown. Because right now I can't look at this and say, well, I know what that is. It's not a spot on the unit circle that I know. So I'm going to take the formula for cosine, and yes, you can take multiple approaches to these. I tend to take what I think are the easiest. That's not to say that yours wouldn't be right. The key thing is to make sure that when you split this up, you want to split 195 up so that it's two values that you do know. Like I, for example, chose 150 and 45 because I know the cosine of 150 and I know the cosine of 45. So I take that cosine of 150, cosine of 45 minus sine of 150, sine of 45. Okay, so cosine of 150 is negative root 3 over 2. Cosine of 45 is root 2 over 2. And these are values from the unit circle. If you need kind of like extra support, you can go back and take another look at that. And we've got minus. Sine of 150 is 1/2. Sine of 45 is root 2 over 2. Combine simplify that. So you get negative root 6 over 4 minus root 2 over 4. So now I would write this like that. You can leave it like this. But I would prefer it written as one fraction. What you have to be careful of here is that you don't do this. So that's negative root 6 minus root 2 over 4, because those are two different things. If you would like to do that, then make sure your negative sign stays up top. Okay, if you're going to move it out in front, you've got to take it away from both of them. So just be careful of that. Little things like that can get you. You can know how to do the problem, but then, kind of trip up at the little things. All right, and it works for radians too. So, for example, find the exact value of the tangent of 7 pi over 12. Again, I don't know anything about pi over 12. I can't give you an answer for that. But when I'm talking about radians, if something finishes in 4 or 3 or 2, that I can do. Values of, pi over 4 or 3 or 2. So I'm going to start with easiest one. Say, well, if I want this to simplify to pi over 4, I need to somehow split 7 up. So for me, I immediately thought of tangent of 4 pi over 12 plus 3 pi over 12, because those two together equal 7 pi over 12. So I split it up like this, and then I used the formula for addition with tangent. So just so you can see, I took those two numbers, did that, reduce it there. You can reduce it here if you want, and then get to this step. That's fine. So you have the tangent of pi over 3 plus the tangent of pi over 4 all over 1 minus tangent of pi over 3 times the tangent of pi over 4. So that's tangent of pi over 3 is root 3. Tangent of pi over 4 is 1. Then you got 1 minus tangent of pi over 3 is root 3 times 1. So you get 1 plus root 3 over 1 minus root 3. Cannot leave it like this. No radicals in the denominator, so multiply it by the conjugate. So 1 plus root 3 1 plus root 3. Multiply the top and the bottom by that, and you get 1 plus 2 root 3 plus 3 when you go ahead and, FOIL this out. And then this becomes 1 minus 3, which simplifies to 4 plus 2 root 3 over negative 2. Negative 2 goes into all of this. So I just like to, if I see a negative, I just like to put it out front and change the sign. Makes it a lot easier. So 2 goes into everything. That cancels out. That goes to 2. That's just 1. So that's how I get the negative out. That's from down there. 2 plus root 3. All right, so now proving identities. A couple things to keep in mind when you're using addition or subtraction formulas. Write down each step. If you make a mistake, you want to go back and be able to have all the steps. You might forget what you were thinking from step to step if you don't. And really, it's best to only work one side. And then when you're using the addition and subtraction formulas, it gets confusing if you try and work two. And the other thing is, when you're trying to pick a side to work with, it's actually easier to pick the side that has more terms, because it's easier to whittle it down to something than it is to try and take something that's simplified and expand it out. So just some suggestions. All right, so now I want to verify this is an identity. I want to verify the cosine of x minus pi over 2 equals the sine of x. So I'm going to rewrite the left-hand side using that whole, cosine addition or cosine subtractions. Cosine of x times the cosine of pi over 2 plus sine of x times sine of pi over 2. I don't know cosine of x, so that's got to stay the same way, same with the sine of x. What I do know is that the cosine of pi over 2 is 0. And I know the sine of pi over 2 is 1. Well, 0 times anything is just 0, so that leaves me with just this. And sine of x times 1 is just sine of x, which equals the right-hand side. All right, next one. You need to verify that 1 minus tangent of x tangent of y does in fact equal cosine of x plus y over cosine of x times cosine of y. All right, so first things first, I'm going to change tangent to this. All right, so no like addition or crazy subtraction stuff there. And then you'll notice I'm going to go ahead and, just so you know how I got from here to here, this became 1 minus sine of x, sine of x, not s, sine of x, sine of y, over cosine of x, cosine of y, not minus. Let's just multiply together. All right, so now to combine these, I need them to have a common denominator. So I multiplied both sides by cos of x, cos of y. All right, or multiply the top and the bottom of the 1. And then I simplified them both into one fraction. Now, if you look at this here, that is the addition formula for cosine, which becomes cosine of x plus y over cosine of x, cosine of y, which equals the right-hand side. All right, so now the sum of sines and cosines. You can write this expression that you see here in terms of a single trig function, sine. To do so, you're going to use this. So this is an important formula to know. Okay, this is what you're going to turn this into. So this becomes this, or something close to it. Okay, k, this right here, k, equals a squared plus the square root of a squared plus b squared. And theta is determined by the trig functions on your calculator. Okay, with theta. Okay, so you're going to, let's say, I want to find, I'm going to use a. So I do inverse, since that's with sine, I'm going to do inverse cosine of a over k. Could also equal inverse sine. Since this is sine, I'm going to use this b of b over k. All right, I could go into some detailed explanation as to why that is, but for now, just please understand that you use the opposite. So if I'm using inverse cosine, I use a over k. If I'm using inverse sine, I use b over k. Or basically, you use whatever is in front of the other term. All right, so if I'm going to write this in terms of sine, start out by finding k. So square root of 3 squared plus 3 root 3 squared. So this is 9. That's 27, which is 36, which equals 6. So now we can say cosine of theta equals, let's see, theta. So we've got, this is cosine, so I'm going to use 3 over 6. So inverse cosine of 1/2 is the same as pi over 3. Double check it with sine. So inverse sine. Now again, since sine is here, I'm going to use 3 root 3 over 6, which reduces to root 3 over 2. And that is also at pi over 3. Alright, so what you need to be careful of is this. Let me get rid of all this ink here. Alright, you are given pi x, not just x. So if you go back and look, notice how these are just x. That's just x. But when these are pi x, we have to take that into consideration. So 6 sine pi x, we have to include that in there, plus pi over 3. Well, you can't have anything in front of the x, so we factor that pi out, which is how we get this to the outside, and why that becomes 1/3. So this is the correct answer. Alright, so now to graph a trig function, you do the same thing you have in the past, back in Unit 5, Chapter 5, I believe it was. The only difference is you first have to write the function in terms of sine. So anytime you're asked to graph, make sure you're in radians. So if I have to, first I have to express this in terms of sine, and then I have to graph. So first find k, which is 2, and then I need to find theta. So theta equals inverse sine. Here's sine. Nothing in front, so that has to be a 1. So 1 over 2. So sine is 1/2 at pi over 6. And you can do the same thing with cosine. You can say inverse cosine of, so in front of sine is root 3, which is also pi over 6. Okay, so that gives you 2 sine. Now again, notice, this was a 2x. It had to come down. 2x plus pi over 6. I can't have that 2 there, so I have to factor that out. So the 2 comes out from in front of the x. And remember, when you factor out of a fraction, you're actually multiplying the denominator by whatever that is. So pi over 6 divided by 2 is the same as pi over 6 times 1/2, which is pi over 12. And now to graph that, this 2, remember, is your amplitude. So that means we're going to go up to 2, down to -2. This tells us what our period is. Remember, your period is, okay, I know that we used k in here, so we can call this whatever. It doesn't matter. You take 2 pi divided by whatever that number is, so in this case 2, simplify, so your period is pi. And then we have a phase shift, which means left or right. And since it's positive pi over 12, we're going left. So that means we're going left pi over 12. So we're going to go from pi over 12 to 11 pi over 12 because this is one period. Because this is to the left of the y-axis. We have 1 to the left, 1 over 12 to the left, 11 over 12 to the right, which equals 12 pi over 12, which is just pi, which is what our period is. And then we just graph that with our amplitude. So we've got our amplitude of 2, our period of 1, of pi, and we're good. We've got our phase shift of that. And you only need to mark there and there, just where one period starts and ends. Alright, so some tips. Review your unit circle, know your points on there, in case you do have to use something like your calculator to find your answer for theta in degrees rather than radians, because radians is only going to be if it's something that you can figure out by looking at. And then review graphing trig functions and how the different parts affect the graphs. So that's my little tidbit of information, my little suggestion for you guys. So anyway, have a good one. Take it easy.